Okay, so now we will start with the chapter called Motion in One Dimension. So this is a part of kinematics. You can say first part of kinematics. So let's start this. For that, I first told you about a term kinematics. So first we learn what is this term kinematics. The branch of physics concerned with movement of objects is called so we understand what is this movement thing. In movement we basically learn that what is happening to the objects, you can say physical state. So that first there are two things to describe this chapter, which are rest and motion. Rest and motion. What is this term rest and motion, you basically ask. So let me first describe the definition and then you will understand it. When position of object does not changes with respect to time, with respect to observer. We will discuss this term with respect to observer. First discuss its definition, then object is said to be in rest. I hope you have learned about this in class 9th, basically. Okay, so now let's move to return motion. When position of object changes with respect to time, with respect to observer, then the object is said to be in. Let me discuss one more point related to it and then you will understand it very well. So the third point is rest and motion are related. So we understand its definition. Let's now take example. Let's say this is a chamber of a train. Okay, I hope you have heard of this example. When you haven't, it is not big deal. passengers over here. Everyone is dancing and we are sitting over here. Relaxing out. Okay, so we are on the ground and this is a train, so it is moving with some velocity, we don't know u. And suddenly a robot comes over here, Robert Mangal Singh. This robot has a gun and he is all happy to hijack the train. And he says, stand still. All the passengers stand still. So the robot was very happy that now I can take everything from their jewelry, etc. etc. Yes, this one is a girl, so he takes everything out of it. So what happened is, robot is very happy, but we are sitting over here laughing. No one is listening to Robert Mangal Singh, as everybody is moving with some velocity u, including Robert Mangal Singh. So we are just happy. Well, we shouldn't be happy as this train is being hijacked. Well, back to business. What happened is, in perspective of this document, A and B are at rest, but in perspective to us, are in. So what does this say? It describes the term with respect to observer, not only with respect to time. Okay, so we are clear with this part and we are in motion, including the robot. So from here we see A and B with perspective of robot. Usually A and B are at rest because robot is also going with the same speed or velocity with which A and B are going. So there is a separate part relating motion. We won't be going in that depth. We'll be learning about that in next lectures. Well, for now this is enough for us. So let us erase now. This was a very interesting concept. So we learned about the definition of rest and motion. And we also learned that kinematics is the study of rest and motion. So now what part are we going to study? Let's take a rest. The ball is at rest with perspective to us. Then what is there to study in the ball? That it is at rest and some gravity force is acting over if it is in Earth. So this is just a stupid idea. Things going to happen like that. Then nothing to study in rest. But if we come to motion, there are many things to study. So let's come to describing motion. First is types of motion. So there are many parameters of kinematics and there are many types of motion to study. Well, we are learning about only 3 general types of motion. The first part is motion in one. The second part is, the first part is motion in one dimension. The second part is motion in 2 dimensions. And what is the third part. Motion in 3 dimensions. Well, there are a few more parts like relative motion, constrained motion, etc. Well, these are the 3 general types of motion. So our chapter name is motion in 1 dimension. So we will completely focus on this. We will learn about this motion in 2 dimensions and motion in 3 dimensions later. So for now, let us just focus on motion in 1 dimension. Well, I hope that you will note this part down. Okay, so now we will come to definition of motion in 1 dimension. What is this motion in 1 dimension? Definite. Okay, so let us first tell it in very crude way. When only one coordinate changes with respect to time with respect to observer, then this is the case of motion in 1 dimension. So this is called motion in 1 dimension, and let us take one example of motion in 1 dimension. Let's say this is a flying kite. So is it an example of motion in 1D? It is in sky, don't forget it. It is in sky. Definitely not. This is not example of motion in 1D because over here y coordinate also changes and x coordinate also changes, which is not appropriate to describe motion in 1D. Motion in 1 dimension. So some examples are like this is a straight path or anything like that. So like this, there is any car moving. This is an example of motion in 1D. It is a road. That 2 coordinates doesn't change. Okay, I hope you understand till now. So I want that you guys note this part down. Okay, so what is there new to learn in this first part? So there are many things. This is part only an introduction of this motion in 1D on itself. So we will start with parameter of kinematics. Parameters of these are universal for all types of motion. So there are total 5 parameters of kinematics. There are 5 parameters of kinematics. What are them? Which are first one, distance, second one, displacement, what is the third one, speed, what is the fourth one, velocity, acceleration. These are the 5 parameters of kinematics. They are one parameter of kinematics. Rather than that, so we will have to start with distance, displacement. So how will we start with it? Its definition. Well, these are very small topics, distance and displacement. We will cover it very quickly. First, we will focus on distance. What is distance? Can anybody tell this definition? Yeah. The actual length covered by the particle is called distance. So this was very simple actually. Let's say take an example. Particle travels like this. Then this is going to be its distance, no matter what happens. Okay, now we'll come to displacement. What is displacement? The shortest length between initial and final. Position is called displacement. For example, let's say this is our house. And this is somewhere a very big city which we have to, what is that, we will be tourists over there. So distance which we covered is like this to this city. And the only road is also this, but the way could be like this. So this will be called displacement. This shortest way, and distance could be anything like this, wherever the particle goes. Over here particle is us. So this was an example, basic example of distance and displacement. Okay, so let's discuss which type of quantities they are. Distance is a scalar and distance is a scalar quantity and displacement is a vector quantity. So I am asking a simple question. What is vector quantity? Don't know? Oh, it was very simple. Vector quantity are the type of quantities which have direction. The definition: displacement has a direction, the shortest length has a direction, and displacement has no direction. Wherever you go, it is called distance. Displacement is a vector quantity. That's why, and distance is a scalar quantity. The SI unit of distance and displacement is meter. So what is going to be its dimension? As its SI unit is meter, its dimension is going to be L, means length. So these were some of the basic factors of distance and displacement. Should we cover speed also, or half of a speed? You guys will tell me. Okay, so let us just end this right now. Many people are saying this. So I hope you liked the video. And this was the first part of motion in one dimension. There are going to be a few